Okay, so we on Tuesday, stopped with symbol calculations. So we covered this. And the next topic that we need to discuss is that of name assignment. Now, to introduce this, we're looking once again at this example of the free-falling object that you've studied at school with initial position, a zero initial velocity, gravitational acceleration. But now, different from the previous problem, they tell us it's falling for 1.5 seconds, and it wants us to calculate how far it has fallen and also what's the velocity after 1.5 seconds. So it's not like hitting the ground, it's just falling. Right, so to calculate the velocity, we can use this equation. And to calculate the distance that it's fallen, we can use the bottom equation here. So the Python calculation is done in a slightly different way now than what we had yesterday. So please take note of this and compare with what we did yesterday. Although the example was not exactly the same, it's just a matter of calculation that we'd like to illustrate here. After all, we're not studying physics. Right, so what you'll see in this cell are two print statements. Now, the first print statement, you'll see that between brackets, it has some stuff. Please note that the notes, that's not the class notes, the study notes, which I mentioned to you is not updated. It still uses Python 2. In Python 2, you could have print space and then something that you want to print. That does not work in Python 3 anymore. Python 3 only accepts print and then brackets. And whatever is inside the brackets, that's what's going to be printed. So what I'm doing here is I'm nesting a calculation inside the print statement. So it's almost like combining two different things. What I have inside the brackets is a mathematical or it's a computation with numbers. It's not algebra, it's just number calculation. But that is nested inside the print statement. So the print statement will then print the answer of this calculation. And if you look at the calculation, the zeros, of course, this calculation is really the velocity calculation. The initial velocity is 0. That's the reason why there's a 0. And then the AT is the minus 9.81 times 1.5. It's 1.5 seconds. So statement 1, there you can see there's a label 1. By the way, you can toggle this line numbers on and off. If I think it's over here. There's toggle line numbers. If I toggle the line numbers will disappear. Sometimes you don't like the line numbers there. But for teaching, of course, the line numbers is useful because then I can refer to a line. So I'm going to keep it on. So line number 1 is going to print the velocity after it's been calculated. Line 2 will then print the displacement because the initial displacement is 30. The initial velocity is 0, so this term falls away. And then the third term is what is calculated in that part there. I mean, there's the 1.5 squared times 8, and then, of course, a half. So let me execute this cell, and you can see there are the answers. The initial, not the initial, the velocity is minus 14.715. In other words, it's downwards because upwards was taking us positive. And then the amount by which it's fallen is 18.96 meters. Right. So this was one way of doing it. But now we're going to, by the way, this method is really the same that we did on Tuesday, with the only difference is that we've embedded the calculation inside the print statement. That's the only difference. But we are going to now look at yet another different way of doing this. And with that, we're going to use names. Now, to do this, I'm going to first of all load NBTutor. Now, if you looked on a ClickUp, under the software, it advised you, there was an advisory that you should install NBTutor. You can use Python without using NBTutor, but then the notes, the moment you get to this point in the notes, it will crash because it will tell you it doesn't know what NBTutor is. NBTutor is really just a little tool that helps us to show what happens inside a cell. And you can even use NBTutor if you're writing perhaps a more complicated program than what we do initially. And let's say you've got a problem, you see that your program doesn't work well, and you want to study what's happening inside this cell in the different steps. NBTutor allows you to execute the cell step by step by step, and it shows the values. So it's a very useful tool, not only for me to show you things in class, but also for you to use once you try to debug a program. The word debug is used to fix the errors in the program, right? So you can use that. Of course, you need to install it. Now, having installed it doesn't allow you to use it. You need first to load it. So this %load_ext NBTutor will load it. When I execute this cell, nothing will happen. So let me execute it. I press Control Enter. And sorry, I think the cell was not selected. So let me try this again. And so there NBTutor is loaded. By the way, you may have noted that before the cell is executed, this is blank between the square brackets. While it's being executed, that little circle, well, while any program is being executed, whether it's a single cell or a whole program, that thing turns black. And then inside the square brackets, it turns to a little star. And the fact that it's now a 3, and no longer a star, means that it has completed the execution of that cell. So now I want to execute the following cell. And in this cell, I'm going to do exactly the same calculation as what we've done here, except I'm going to now assign names. So I'm going to select a name S0. It's just a name. I could have called it John if I could spell John, right? So it's just the name S0, but of course the reason why I select that is the name S0, it really corresponds to this initial height, right? And so I set S0 equal to 30. In the same way I set V0, that's another name, equal to 0, that's the initial velocity. G is just a name, a name that I've chosen, I put that as minus 9.81, and I select the name T, and I put that I set that equal to 1.5. What I'm really doing here, but we'll explain this in a little bit more detail in a moment, is I'm assigning the numerical values on the right-hand side to the names on the left-hand side of the equal sign. And then after I've done that in line 7, I can then calculate the velocity V in terms of the names that I've assigned. So it's almost like doing algebra, except that the algebraic variables now has values. And then if the computer then knows the values of V0, G, and T, it can actually do this calculation on the right-hand side. And then this line is once again an assignment to a name. I've selected yet another name, just V. Of course, it's a logical name in this case, but I could have called it Peter. But so now I call it V because it's the velocity I'd like to calculate. So doing V equals and then the calculation on the right-hand side will calculate that numerical value and assign that to the variable V. And likewise in record 8, I'm calculating, it's really the same calculation that was here in record 2. I'm calculating that value and assign it to the variable S. And S is once again a name of a variable. And then in record 10 and 11, I print V and S. But now when I execute this cell, it's going to, with the fact that I've now loaded NBTutor and I start the cell with this double percentage NBTutor minus R minus F, will allow me to execute this cell step by step, and we can then see how the values are actually calculated. I'll show you that in a moment. Let me just mention the minus R here tells NBTutor to erase everything in Python in the program. And we'll explain that a little bit later again. And then the minus F tells NBTutor, do not question this. Now, if you leave out the minus F, okay, if you leave out the minus R, it will not erase the variables. If you include the R, minus R, but you leave out the minus F, it will come back to you and say, it's now going to erase all the variables. Is that really what you want to do? And then you can say yes or no. But sometimes you don't want it to ask you that question. If you're sure you want to erase the variables, then you can put minus F, then it will not ask you the question, it will simply erase the variables. Right. So let me start this cell. I hold down Control and I hit Enter. So you can see now it split the cell into two columns with a scroll bar at the bottom because it cannot fit it on the screen because I've zoomed to 200%, but that's so that the people at the back can see. Can you actually see? Is it large enough? Okay, thanks. So I have this scroll bar at the bottom to at least be able to see what's in the right, towards the right. That's cut off by this vertical line. And there, on the right-hand side, it shows in this blue color global frame. Now, I'll get back to the global frame in a moment. You'll also see at the bottom it says a red arrow indicates the next line. That means the next line that will be executed. Green, there's no green arrow yet in the cell, but green is the previous line, and blue means waiting for the next frame. So if I now just scroll up a little bit, you'll see that there are now some buttons at the top. So this is specific to NBTutor. Normally, Python will not have these buttons, but if you run NBTutor, you have these buttons. And if I click on Next, it will execute the next line. Now, the next line is indicated with a red arrow as line 2, so it will assign 30 to S2. So let me do that. I click Next, and now you can see under global frame, there's now a variable S0, what is on the left-hand side of line 2. Remember, it now executed line 2 only. It's now indicated with a green line because it's the previous line that was executed. The next line that it wants to execute is line 3. But after having executed line 2, the variable S2 has been assigned a value, and therefore it shows you at the bottom, here's S0, sorry, not S2, S0. Here's the variable S0, and it shows you that the value that's assigned to it is now 30, and it shows also that it's an integer. If I add the 30.0, it'll show me it's a floating point value. In fact, we'll see that in line 4 and 5. Any questions up to now? Okay, so let me do next again. And so now record 2 has been executed, and I have V0, and it's an integer value of 0. If I press next again, record 4 has been executed. I've defined variable G. And now you can see it's not an integer, it's a floating point number. Do you know what's a floating point number? You know what's an integer, right? Now, a floating point number, you can almost think of that as the complement of an integer. In other words, when you do have a fraction, when you do have a point and then something behind the point, behind the decimal point, right? That's a floating point number. That's terminology in the computer world. By the way, there are also other ways of referring to floating point numbers, but for now, you can just think of a floating point number as a float. Okay, so we can see that G is a float. If I now do next again, T has been defined, and we can see that T is also a float. You can see that if I hover my mouse over these variable names, it of course changed to red, and the arrow changed to red, and the value also changed to red. Because sometimes if you have lots of variables, the right-hand side here gets quite messy, and the arrows may actually cross. But so when you hover over it, you can see where the arrow actually goes. Right, and so let me complete this, calculate V. Now this is the result of the calculation. It says minus 14.7, and if we scroll up, we can see it's actually minus 14.715. You can actually tell NBTutor how many decimal values should be displayed, but it's by default, in this case, just 1. And if I then execute record 8, okay, I need to scroll down a little bit to do that, then S has been calculated. So here you can see the arrows don't cross yet, but it's almost a crossing. It says S is 19, and we see that it's quite close to the value that we had before. To 1 decimal point, it is actually 19. Right, but it shows you that even though there is not a point, it is a floating point number because it's really 19.0. And then the last two statements is just to print it. You can see there's nothing below here, but the moment I execute record 10, you can see that it's now printed it as minus 14.715, not the abbreviated one like that we have here. And that, of course, is exactly the same as what we had before. And if I then execute the last line, it shows me, it prints S as 19.96 rather than, 18.96 rather than the 19 that was shown in NBTutor. And that has completed the calculation with a cell with NBTutor. Right, so we've illustrated two things here. We've illustrated basically how NBTutor works. That's not so important, but you may perhaps use that when you try to debug a program. But the main thing that this cell showed is the assignment of numerical values to variables and the calculation of a result on the right-hand side, and that result being assigned to a variable. Are there any questions about this? Yes? Yeah, okay, I think your question will be answered as we go on a little bit. You know, we will see different things being assigned to variables or to names. It's not necessarily a variable, it can also be something else. But I think hold your question, and if it's still not been answered later on, then please come back to me with that question, right? Any other questions? Yes?
So if you write the numbers and the codes in the normal markdown, you change the line to big?
No, it's important. Thanks. He's asking whether this is written in Markdown. It's not. It's in a code cell, right? So let me go back here, and I need to switch on the toolbar. So if I click on this cell, that's Markdown. So it's just text, right? But the moment I click here, it's code. And the moment I click here, it's also code. So whatever you want Python to execute as a computer program, that should be in a cell that is code, or it can be a number of cells. We'll get back to the execution of a number of cells a little bit later today, but we focused for now just on executing a single cell, but it's certainly code, Python code. Okay, does that answer your question? Okay.